Welcome to the first unit of your Gcse level physics, electricity, energy and waves. Firstly, let's zoom to the term electricity. As we know, electricity is used by us throughout the day for heating, charging the electrical devices and so on. Even when you try to escape from electricity, it is a bit difficult because it is still at work throughout nature, from the lightning in a thunderstorm to the electrical signals in the human body. So, how exactly we can define electricity? Electricity is briefly defined as the flow of electric charges. But there is so much behind this simple statement. What are these electric charges and where do they come from and so on? To begin to explain electricity, let's start from the atom that makes everything we can interact in life. An atom is built with a combination of three distinct particles: electrons, protons, and neutrons. Each atom has a center nucleus, where the protons and neutrons are densely packed together. Surrounding the nucleus are a group of electrons, and these electrons are always orbiting. Electrons always carries a negative charge, and protons are positively charged. As the name indicates, the neutron has zero charge, or this neutron has no charge. Electrons in atom can act as charge carrier because every electron carries a negative charge. If we can free an electron from an atom and force it to move, we can create electricity. So, we can define electricity as flow of electric charges or the flow of free electrons. In order to learn the flow of free electrons, which enables us to light a bulb or to charge a phone, we need to have a look at electric circuits. This is the basic model of an electric circuit. Here you can see bulb is lighted with the help of a cell or battery when the switch is on. In physics, we use circuit diagrams like this to represent the electric circuit. We use a range of symbols to represent the components in a circuit diagram. As you see here, this represents a lamp. This is the cell. The long line represents the positive part of the cell and short line represents the negative part of the cell. This illustrates the closed switch. Closed switch means the switch is in on condition. So how will you represent the switch when it is in off condition? Here you go. It will be in this open condition. So this is open switch. Looking back to the circuit diagram, we can see that components such as lamp, cell, and switch are connected by wire which is shown as lines. When the switch is on, it pushes the free electrons from the negative side of the cell. The free electrons with a negative charge moves through the conducting wire. As a result, bulb glows. Once the switch is off, free electrons stop moving and the bulb goes off. Even though free electrons flows from negative side of the cell to the positive side of the cell, we always represent the direction of current flow in its opposite direction with an arrow mark. Components with the direction of current flow makes the circuit complete. There are two types of electric circuits. They are series and parallel circuits. We will be discussing about them in the next video. Before watching the next video, go through the symbols of a few components and learn it. Thank you for watching. Goodbye.